Let f be a function which maps integers to integers by the following rules. F at n is n minus 3 if n is greater than or equal to 1,000. F at n is f at n plus 5 if n is less than 1,000. Find f at 999. F at 999. All right, well, I think we simply just have to abide by the rule. So f at 999, well, 999 first of all is greater than 1,000 or less than 1,000. It's less than 1,000, so we have to go with that rule. So that's going to be f at 999 plus 5, which is 1,004. Okay, so this guy, well, 1,004 is greater than 1,000, so we're going to use the first rule. So that's n minus 3. So it would be f at 1001. And then f at 1001, well, 1001 is greater than 1,000, so again, use the first rule. So that would be 998. And I think that takes care of that part. Show that f at 984 is f at 1004. Okay, so I'm not gonna write the brackets. It's getting a little too much of a ordeal to write the brackets, so I'm just gonna write just f. So I'll write like f at like that without the brackets. Okay, so we've got f at 984, and then we have these three f's, 1004. Okay, so we have to prove that that equals that. So this is left side and this is the right side. So let me just start with the left side and let's see what I can get. And then if the left side eventually equals this, then I've proven it. So here we go. And then of course, these are my two rules, and I'll just keep those in the screen just so you guys know. Okay, so left side is equal to f at 984. Okay, so I'll just do this quickly. I'm not going to walk you through every single one because I don't think you need me to. It's just look at n. If n is greater than 1,000 or equal to 1,000, you use the first rule. If it's less than 1,000, use the second rule. So here we go. Okay, so that will be f at 989, and that's going to be f at 994. F 999, and then 5 f's. Keep going. 1004. Okay, now we can use that other rule. We can drop it down now. F 1001. 4 f's, I guess. Well, yeah, 4 f's. And then 3 f's. 998. And looks like we got to go back up to the use the since it's 998, we have to use the second rule. So we have f, and then adding 5, so 1003. Okay, 1003, so minus 3, so 1,000. So we're playing this cat and mouse game here, and then this will be 997, and then this will be 1002, and this will be 999, and then this will be 1004. And that's it. I got this. So that's right side. So it's a bit cumbersome, and it might be a little confusing, but it really shouldn't be, right? Because it's just two functions, and you're just flipping back and forth depending on the value of n. Okay, so that's that. And now we get to the final one, f at 84. Okay, so the first two, right, parts, A and B, should help with this third part, trying to figure out f at 84. Because we got that, let's see here, the first one, we figured out that f at, well, we got quite a few. We got f at 1001, which was 998. And we figured out a lot of these. F at 1,000, well, that's very quickly. You can do that just from those two functions. It would just be 997. F at 999, that is, I think we got that somewhere here. I'm not sure where, but you can easily calculate that. That would be f at 999, right? Didn't we do that somewhere? Oh yeah, the very first one. I knew that we had done it somewhere. That's 998. Yeah, f at 999 was 998. And then f at 998, you can do that very quickly. That would be f at 1003, and then that would be f at 998. Oh, sorry. No. You subtract 3, so it'd be f at 1000, and then that would be 997. So you might be seeing a pattern here. I'll just go a couple more, and I'll let you guys do these. 997, I'll let you do it. And when you do, you'll get 998. And then I'll do one more, f at 996, and that will be 997. So I think hopefully by now you get to see a pattern that f at n is 998 if n is odd, and f at n is 997 if n is even. Sorry, I think I wrote the 977 there. It should have been 997. Okay. So hopefully that is the pattern that you are convinced with. So f at 84, well, since 84 is an even number, it will be 997. So that's how you do that. Find the distance from point 10 to the line connecting the origin and point 10, or 01, sorry. So let's try, we have 10, so this is 10, let's say, and this is the origin, and the point 01. So that line is basically that line right there. And the shortest distance, which I assume they're asking, would be just straight from that point to there, which would be a distance of 1. No. Next one, find the distance from 10 to the line connecting the origin and the point 11. Okay, this time is a little different. So we have 10, which is sort of the same point, but now we're connecting it to 11 and the origin. So the line that we first have to create is that line. And the distance, I'm assuming the shortest distance. So the shortest distance will obviously be perpendicular when you draw it. So this is 10, and that's the line that connects 11 to 00, which is the origin. And that can easily be figured out as y equals x, right? That's the only line that it could be. So then how do you figure out the distance? Okay, well, I will concentrate sort of on this triangle right here. I'll drop that down. I'll drop down this right here. Right here, like that. Or you can, it doesn't really matter. But when you do that, this is going to be a half, and that guy is also a half. And the reason is because this point right here, that is of the form xy, but since y is equal to x, it's of the form xx. So it has to have the same x coordinate and y coordinate. And the slope has to be a negative reciprocal of that slope. The slope here is 1, so the slope of this line has to be -1, which is the negative reciprocal. So there's many reasons why you can conclude that that is a half. Okay. And I think a little bit better way of explaining it would be as follows. So if we have this point 10, right? And then we have the point 11, which is right there. So if you draw a line between them, the distance is going to be perpendicular, right? And that point is xy, but it's actually xx. Why? Because that line is y equals x, and you can easily figure out the equation of that line. Then we should, just for the sake of completion, figure out the equation of this line, and that line, I'll let you do it. I'm certain you can do it. It'll be minus x plus 1. So really what you're doing is trying to find the intersection point of these two lines, and when you do, you will get 2x equal to 1, therefore x is a half. So that point is a half, a half. So if I were to take that triangle there and kind of draw it here, that is a half, that distance is a half, and that distance is really what we're trying to figure out. So then you just use Pythagoras. So it would be d squared is a half squared plus a half squared. And that means that d squared would be a quarter plus a quarter, which is a half. And therefore d would be 1 over root 2, which is root 2 over 2 when you rationalize the denominator. Part C, the distance from point 1, 0, 0 to the line connecting the origin and the point 1, 1, 1. Okay, so this time, now we're getting into 3D here. So since we're talking about 3D, I will just draw a cube of side length 1. I think that's the easiest way of doing this to avoid confusion. Okay, so that is a cube of side length 1, right? So if we're going from 1, 1, 1 to 1, 0, 0, that would be what? That would be the equivalent of going from where to where? Well, first of all, the point 1, 0, 0 would be here. And I don't want to draw the coordinate axes. That's going to make it confusing. Let me just stick to the cube. That's the point 1, 0, 0. And then we're not going to the point 1, 1, 1. We're going to a line that's connecting the origin to point 1, 1, 1. So that's a little bit different. So let me draw on that line. That's going to be this line right here. So this is the origin right here. That's the 0, 0, 0, 0, basically. 0, 0, 0. And then this point up top here is the 1, 1, 1. And then we got to connect those. Okay, so let me think about this for a second. Okay, I think we're going to have to use areas, and let me explain first. Yeah, let me first explain it. In order to first figure out the diagonal, we're going to have to draw in another line from there to there. And that will allow me to figure out all these dimensions. Okay, so here we go. This dimension is 1. That diagonal that's flat, if I were to draw it, I'll draw it over here. That is 1 and that is 1 and that is D. And that's a right angle. I mean, it's not drawn in a way that it looks like a right angle, but that's the way it is, right? Because it's a square. So that means that D squared is 1 squared plus 1 squared. So that means D is root 2. So that means that we now would have to figure out the big diagonal, the one that's going from here to here. And that one I will draw here, and I'll call it big D. That's 1, and that is just root 2, which is what we just figured out. So then to calculate big D, again, Pythagoras, 1 squared, root 2 squared. And that looks like D is going to be root 5. Let me see. Oh, wait, hold on. Let me see if I did that correctly. 2 plus 1. Oh, boy, that's really bad, right? Root 3. All right. As long as I can count, I should be okay. All right, so then what are we trying to figure out here? We're trying to figure out the perpendicular distance from this guy to here, right? That perpendicular distance, like that. Okay, so now we are pretty much set to figure this out. I just have to draw in one more line, and that one line is from here to here. So here we go. And I'm going to have to then draw them in the 2D versions to make you understand them. And let me label it A, B, and C. So in that triangle ABC, which is sort of like this is A, this is B, and this is C, in 2D, and that's a right angle. So if I were to figure out the area, it'd be 1/2 base times height. This is the base, which is 1, right? And that height is the distance from B to C, which you can easily figure out is root 2. right? Just how we figured out that it's a diagonal, basically. So that means that the area is root 2 over 2. But what the good news is that you can also figure out the area of ABC using this AC, 1/2 base times height. AC is the base, and that perpendicular distance as the height, which I guess we'll just call H for now. We'll just label it H. It's that H right there. And that is what we're trying to figure out. So since that's root 2 over 2, this an AC is what? That long diagonal, that's root 3, right? Okay, so 1/2 root 3 H. So that basically means it would be root 2 over root 3 is H. So if I rationalize the denominator, I will get root 6 over 3. So there you go. So that took a little bit of time there to figure out that distance, and that is root 6 over 3. Alice and Bob are playing a game. There are initially n greater than 1 stones in a pile. Alice and Bob take turns, with Alice going first. On their turn, Alice or Bob roll a die with the number of faces 1, 1, 2, 2, 3, 3, and take at least one and at most as many stones from the pile as the rolled number on the die. The person who takes the last stone wins. If n equals 2, what is the probability that Alice wins? Let us discuss this. Alice and Bob. So the roll and the probability. So if the roll is 1, n is 2, right? So there's 2 stones. So if the roll is 1, the probability that Alice wins, well, what are the possibilities? There's on the die a 1, a 2, a 2, and a 3, and a 3, right? So the probability of rolling a 1, there's 2 1s out of the 6 numbers, so 2 out of 6, which is 1 over 3. Okay. And then if the next roll, there's going to be, since she rolled a 1, she removes 1 stone. So then 1 stone remaining here. And if Bob rolls a 1, he can then remove that 1 stone and win. So the probability of him getting a 1 is, again, 1 over 3. But he will also win if he rolls a 2 or a 3, because the question is kind of interesting that you can take at least 1 and at most as many stones from the pile. You don't have to take exactly the number of stones that are on the die. And you see what I'm saying? Like if you roll a 2, you don't necessarily have to take 2 stones because there's only 1 stone left, so you can only take 1 stone. So in this scenario, Bob wins when Alice rolls a 1. So we want a scenario where Alice wins. Okay? So Alice would win if on her first roll she rolls a 2. And the probability of that is 1 over 3, right? Because the same story, there's 2 of them out of the 6. But she can also win if she rolls a 3, or Alice rolls a 3. Because if she rolls a 3, then since there's only 2 stones, she just removes those 2 stones. So this or that. So you add them if it's an or situation. So 2 over 3 is the probability that she wins if n is 2. What is the smallest value of n for which Bob is more likely to win than Alice? Okay, so this is going to require a little bit more calculation, obviously. So here we go. So what is the smallest value? Well, let's just go one at a time. When n is 1, who goes first here? Alice goes first, right? Yeah, Alice goes first. So if an n is 1, then no matter what Alice rolls, she wins. If she rolls a 1 or 2 or 3. So her probability of winning, let me just make a little table here. Probability of winning for Alice here is 1, and for Bob it's 0. So that's for n equals 1. How about n equals 2? Well, n equals 2, we just did. The probability of Alice winning is 2 over 3. And therefore the Bob would be the complement, which is 1 over 3. Right, because the total probabilities have to add up to 1. Because that we did that up here. So that's fine, that's done. So then we just keep going here, and n equals 3. And then the hope is that, what is the hope? What are we trying to get here? What is the smallest value of n for which Bob is more likely to win than Alice? So we want to get an n for which Bob's probability is greater. Okay, so far Bob is less than Alice in terms of probability, right? Because 0 is less than 1. This is also less than A, because 1/3 is less than, let me just put that here. I should just put that there. Yeah. So we want a scenario where Bob is greater, the probability is greater. Okay, I got it. All right, so here we go. N equals 3. Okay, so if Alice chooses a 1, the probability of that is 1/3. And then Bob, for him to win, he can do it if there's 2 on the dice or if there's a 3. And the probability of a 2 is 1/3, probability of a 3 is 1/3, so you have to add these guys. So that's 2 over 3. So, okay. But that's only the scenario if Alice rolls a 1. What if Alice rolls a 2? If Alice rolls a 2, 1/3 probability of rolling that, and she let's say she takes so Alice is going to only take 1 stone, because if she takes 2 stones, then what happens is guaranteed Bob will win on the next roll, because even if no matter what he rolls, he'll be able to pick up that last one. So she's trying to get a strategy here to at least be competitive. So that's why she's only going to take 1 stone. So then Bob rolls a 2 with a 1/3 probability, and since there's 2 stones left, he takes them both and wins. Or Bob could roll a 3 with 1/3 probability, and again he wins. So then you have to add these guys, and again it's 2 over 3. Now if Alice rolls 3, then of course she just wins automatically, because there's 3 stones, and Bob would lose, so his probability of winning is 0. So then we have to add all these guys up. So Bob's probability of winning is this and this and this, and there's a 1/3 chance of this scenario happening, and then 2/3 was his probability of winning. A 1/3 chance of that scenario happening, and a 2/3 chance of Bob winning, and a 1/3 chance of this scenario happening, and a 0 chance of him winning. So when you add all these up, it's 2 over 9 plus 2 over 9, which is 4 over 9. So back to our tally, A and B. Bob winning is 4 over 9, and therefore Alice winning is 5 over 9, which is of course the complement, because they both have to add up to 1. And this is still less than that. So n equals 3 still is less than. So we got to keep going here. Hopefully we don't have to go too far. Let's try n equals 4. N equals 4 again. Alice rolls a 1, and she does that with 1/3 probability. She takes only 1 stone. And then Bob has 3 stones. There's 3 stones remaining. And then Bob rolls whatever. At this point, since there's 3 stones remaining, it basically becomes a scenario as before, but this time instead of Alice going first, Bob's going first. So you can do this same process again, and you will get the same probability, but instead of getting 4 over 9 for Bob, you'll get the complement. You'll get 5 over 9 because this time Bob is going first. You've kind of, that one action turns it into this scenario with Bob going first. So it'll basically be the reverse of that. So this scenario will be A, B, it'll be 5 over 9 and 4 over 9. And since that is greater, that's the first time where Bob's probability of winning is greater, and that happens when n equals 4. Find all values n for which Bob is more likely to win than Alice. So we have this recursive formula, and the explanation of how this recursive formula has been obtained is up here. This whole explanation, I encourage you to read it and understand it. So then, since we already have a bunch of these, remember when we had n equals 1, the probability, it was originally for Alice and for Bob, right? So the probability for her was 2/3, and this would have been 1/3, and that was for n equals 2, I believe. When n equals 3, the probability was 5 over 9, and Bob was 4 over 9. N equals 4, we got 4 over 9 and 5 over 9. Now, Bob more likely to win if his probability, Bob is more likely to win, probability is greater than a half, right? If his probability is greater than a half, or the other way of looking at it is if Alice's probability is less than a half. So let's see here. Let's see if I can apply that to these numbers first and see what happens. They should be fairly straightforward in the first few. So Bob is more likely to win. If n equals 2, Alice is more likely to win, right? Because A is greater than a half. In n equals 3, who's more likely to win? Alice, because A is greater than a half. In n equals 4, Bob is more likely to win because B is greater than a half, or A is less than a half, whichever way you want to put it. Okay, so then if you apply this recursive formula, you'll be able to get other for n equals 5, n equals 6, n equals 7, and so on. N equals 8, n equals 9. And then we can see if there's any some sort of a pattern that we can sort of generalize. So I'll just figure out P5 using that. So P5, according to that, would be 1 minus 1/3 P4 plus the minimum of P4 and P3, correct? Plus the minimum of P4, P3, and P2. Okay. So that looks like 1 minus 1/3. P4 is, we're just looking at these values because we're going to calculate them for Alice, and then Bob would just be the complement. So that would be P4 is 4 over 9 plus the min of P4, so the min of P4, which is 4 over 9, and P3, which is 5 over 9. And then plus the min of 4 over 9, 5 over 9, and 2 over 3. Okay, so that looks like 1 minus 1/3 times 4 over 9 plus, well, that looks like 4 over 9 is the min of that, and the min of those three numbers is 4 over 9 again. So that looks to me like 4 over 9 plus 4 over 9 plus 4 over 9 to the times 1/3, which would just be 4 over 9. So it would be 1 minus 4 over 9, and that's 5 over 9. Okay, so that means P5 is 5 over 9. And then I don't even think you need to calculate the Bob's value. You can if you want. Just look at the Alice's value, and if it's less than a half, then Bob will win. Is it less than a half? No, it's greater than a half. Okay, so the ones that Bob wins, let's just see, let's circle them. So wherever B was greater than a half, B was only greater than a half here so far. Okay, so similarly, you would calculate all the other P6, you know, all P7, all that, using the recursive formula right there. And when you do, you'd get the following numbers. You get 14 over 27, 41 over 81. For n equals 8, you get 40 over 81. For 9, it would be 41 over 81. For 10, it would be 122 over 243, 365 over 729, 364 over 729. Now, we're going to circle the ones where the value for Alice is less than a half, right? Because that would mean that Bob would win. So when is it less than a half? Let's see, that looks like it's greater than a half. That's greater. That's greater. This is less than a half. That's greater. That's greater. That's greater. This is less than a half. So I'm pretty confident that since it's n equals 4, n equals 8, n equals 12, any n that's a multiple of 4 will produce a situation where Bob wins.